Okay, this lesson is in chapter 6 of dealing with function composition. Two main objectives. Can we perform the basic operations of functions, i.e. subtraction, addition, multiplication, division, and can we understand the notation, especially when it comes to nesting and composing one function in front of the other. So let's first talk about function notation. Okay, it says here, function can be used any input and any letter function. Just like in algebra, where an unknown quantity can be any one of the 26 letters, okay, and then some symbols and stuff too. But we use different letters to represent different things. Well, just here, the F is a letter that represents the different functions, okay? So this is where the letter represents the function itself, okay? So what we have here is function F will be different than function G or function B. A lot of times we see F a lot just because we see like X a lot, for instance. It's easy to use over and over. But when we're talking about different functions, you have to use different letters. Okay, the letter inside the parentheses, that's your input, okay? So a lot of times we're talking about, y equals mx plus b. Well, x is the input, and y is the function there. So here we have F, again, is the function notation, and that designates the type of function it is, what letter it is. So it's like the variable for the whole thing. And the x is telling you it's a function of this input. So this all works together as one big thing, but it's composed of two letters, the input and the function. So let's take a look here at this example. So when I see this, g of y, the y is the input. And g is the same, g is different than f. This tells you which function it is. And there's no magic YG, it could be any letter, okay? The next example, function k. This makes it distinguished from the other two, saying that it's a different letter, so it's a different function. And here we have a different input, and notice it's over here, okay? So if I said, all right, let's take a look at k of g. So if I said, what's k of 2, I would take every g and replace it with a 2 and then raise it to 1/2 power. So we're evaluating by plugging 2 in. So that part hasn't changed. So let me just do it again here for the g. So if I say g of -3, you would say, all right, -3 cubed minus 3 times -3 plus 5, and you go ahead and evaluate and get an answer, okay? So the input part hasn't changed. The only thing that's really different is we're using different letters to represent different functions. All right, so here we have, let's kind of go to a full screen here if we can, is two functions, f of x and g of x. They both have the same input of x, so that means they can kind of talk together in the same language, but they're two different functions. So we're saying, okay, we're going to make a new function of h. And h is composed of function f being added together with function g. Well, let's go ahead and do that. I'm going to use a different color here for g. Let's use blue. And we say, all right, same different color here as well. We can simply say, all right, 5x plus, and then g of x is x plus 2. And say, okay, those are the two items put together. So what does that equal? We have like terms. 5x plus an rx is 6x plus 2. So we can simply say, keep that there, that h of x is equal to 6x plus 2. Okay, all we did was simplify. So h is composed of f and g being added together, combining like terms, and see what we have here. Same thing here. Let's say h of x this time, I'm just using h of x again, so different examples. So here we have 5x minus, okay, now notice I'm going to use parentheses here because I'm subtracting the whole function. So what we really have here is h of x is equal to 5x minus x, which is 4x, and then we have minus 2, and we have that for our final function. Okay, so I'm just going to highlight some boxes here what we have going on. Then we have ourselves two more examples down here. Multiplying. So we're going to take 5x times g of x, which is x plus 2. And again, it's just the distributive property we saw before. So h of x, notice I like to use the notation, so I'm illustrating what it is. H of x now is 5x squared plus 10x. And now we have a quadratic. So that is the answer to that one there. Okay. Now there's one other thing here. When we divide, notice what we have here, let's write down the bottom here, is we have on top 5x, and then on the bottom we have x plus 2. Okay. Now again, that's all it really gets simplified down to. But notice here, what are the domains? Okay, so really, for all the ones above it, the domains aren't restricted, any real number. But here, what number can't we have in the bottom? Well, here, we cannot have x equal -2, because if we plug -2 in, then we're going to get 0. So I'm going to say x does not equal -2. Any other real number will work. Okay, so we'll see that more when we get to graphing. But when you have division problems, remember, there are domain restrictions. Okay, now, on this slide here, this is where it gets a little more complicated. We're going to nest the function. And what I mean by is, let's use again red for f of x and blue for g of x. Okay, so kind of follow along with the colors. When I see this, this is saying f of input. And what is my input? Well, my input is g of x. And what's being inputted into g? The letter x. Okay, so when I see this, it says x is being inputted into g, and then that number or that equation is being inputted into f. So I'm going to start from the outside and work in. What is f of x? Okay, so let's just first start. The whole thing is equal to, let's start with the red part, f of x. F of x is 5 times that input. And you say, okay, what is that input? Well, that input is g of x, which is x plus 2. So I am plugging g of x into f of x. Okay? Just like you plug a number into an equation, we're plugging an equation into an equation. And you can do that. And this is what the function notation allows us to do. So then our final answer here is simply going to be 5x plus 10. Okay? All right, so let's take a look at the next example. Okay? So when I see g of x, I really see g of input. And what's being inputted this time? F of x. Okay? So function f is being inputted into g. So when I see this, we see, let's start with the right notation. H of x is equal to input plus 2. Okay? So notice that's where that comes from. Here's your input. Input plus 2. And what's being inputted there is f of x, which is 5x. And then you just go ahead and simplify. So we say h of x is equal to 5x plus 2. Okay? Nothing can be behind here and so forth, so that's what we have. Okay? All right, let's take a look at the next example. Okay? I'm going to give ourselves a little more room here. Change my view. Okay, all right, it's a little better. And move this down. Okay. So now notice what's different here. Here we're plugging 3 in. Now, what we can do is we can pull from the exact same equation. Notice this function and this function are the same. The only thing that's different is the 3. So I'm going to take what we found here and say h of 3 now is equal to 5 times 3 plus 2. Okay? And we're just inputting into there. We don't have to go through all algebra again. Okay? Now, if you wanted to see what it looked like, okay, you could from this top equation, you could say 5 times 3 and input that into the g function. And again, we have 15 plus 2 is 17. So h of 3 is equal to 17. And that's what we have over here. H of 3 is equal to 17. Okay? So that's what we're shooting for. So here we're actually putting input into the original f of x, which is then plugged into the g of x. Down here, again, the same thing. F of x, which is simply 5x, goes on top. And then on the bottom, simply again, g of x. And again, we've seen this one before, so we just put x plus 2 as well. Okay, so that's the same thing. And again, all real numbers except x cannot equal -2. Okay, so that's the point for that one there. Okay, so in this slide here, nesting one function into the other. All right, so we have a couple other things here. Now, when I see this one here, we have 3 functions. Let's do the 3 colors again: red, blue, and green. Okay. So when I see this here, we have h of x is equal to f. Now I'm just going to write this in different colors so we can see what we're talking about. And then j of x, which is this, and then the g of x goes inside here. So that's what I'm seeing. G of x being plugged into f of x, and then we're later adding on the green part, okay, which is j of x. So let's go ahead and figure this out. So f of x is quantity squared minus 4, and then the j of x is simply this -2x. Okay, so we're just adding a negative sign there. And notice I'm going to plug in the g of x, which is x plus 9. So this is all what h of x is. So notice I'm just organizing it here. So now we're going to go through and clean it up and say, okay, x plus 9 squared is simply x squared plus 18x plus 81, okay, minus 4 and then minus 2x. And all we're going to do then is simplify it by combining like terms. So we have x squared in front. We have 16x by combining the x's. And we have plus 77. And that should do it there. But notice how I set it all up. The color is a good way to distinguish what's what. The exact same thing happens here. So notice in this function down below, the j part is green, -2x. So we see -2x. There's your input. When I say x, I'm saying input. And then I say, okay, what's next? The g. Notice the g is next. So there's j, and the g is in blue, I believe, and the g is x plus 9. So I'm going to say input plus 9. Notice I use parentheses. And then the f of x, or the f of 2 now, is simply x squared minus 4. So we have x squared minus 4. And what am I going to put in? A 2. Okay? So that's what it looks like. So if we look at this example here, we can just go ahead and simplify this. Okay? So again, I'm just going to take a couple steps here. -2 on the inside here, we have 4 minus 4, which is 0, plus 9. And that's just simply going to be 9. And we have -18. So h of 2. And really, what I should do is I should put a 2 there. So that should really say h of 2. So let's change that right now and make that correction. If you're going to input something originally, there's no function of x anymore. It's just function of 2. And you put the 2 in there as well. So that's kind of what we're looking at here for function composition. This one here is the exact same example as before, so we don't need to see that again. And what I want you to do is work on the yellow problems for our next class, okay? Which when we get to function composition.